All right, hello and welcome everyone to the Hyperlane workshop for Permissionless Interoperability with Hyperlane. Joining us today is Yorke Rhodes, who will be taking us through this session. And with that, I will pass it over to Yorke to introduce himself and get the session started.
Hey guys, how's it going? My name's Yorke. I'm with the Hyperlane protocol. I've been working on this for around a year. I was kind of born out of last year's ETH Denver and just wrapped up last week in Denver. We did some talks. I'm going to be kind of summarizing some of the takeaways there and kind of what tools are accessible for you guys to work with Hyperlane during the hackathons for East Global. So yeah, without further ado, I'll hop into Hyperlane. So Hyperlane's an interoperability protocol. And before we begin, I kind of just want to share my definition of what interoperability is. So to me, interoperability is composability amongst dApps on different infrastructure. So Ethereum unlocked this composability of decentralized applications by introducing this generalized execution environment we call the EVM. And it did so kind of at the expense of performance. As a consequence of that generalized execution environment, it becomes much more difficult to have kind of highly optimized consensus, basically. And what we've kind of seen over the past 10 or so years in crypto is applications as they want to optimize for performance or kind of capturing other forms of revenue. They begin to move away from these generalized execution environments, which kind of provide composability by default, to maybe like an app chain model or a rollup model where the composability story is a bit less clear in exchange for basically better performance. And in the past, maybe a couple years or so, the Ethereum community has kind of galvanized around the rollup architecture for kind of performance benefits that can be passed on to application users. And so this is kind of exciting because we no longer have to have all of the network being throttled by like a single NFT mint. We can now have rollups take on some of the load there. And what we're seeing in the ecosystem is applications are beginning to adopt these new architectures. So actually, pretty recently, the basically volume of transactions that rollups, which are settling to Ethereum, are processing, has superseded actually Ethereum L1 transaction volume, which is pretty exciting. We're starting to see applications really opt into these new architectures and benefit, or have their users benefit from kind of the scaling properties. But along with those new architectures comes a few challenges. So basically, interoperability between these different rollups is a highly fragmented ecosystem. And this is because there's kind of all these different types of interoperability between these architectures. So the first form that probably most of you guys are familiar with of interoperability is what we call like the canonical bridges of these rollups, which are basically on L1, there's a smart contract interface for doing a deposit to a rollup. And then there's an equivalent withdrawal interface to withdraw your asset from that rollup. And then separately, we have kind of a bunch of these asset bridges that function between rollups that allow you to move assets using smart contracts between rollups. And so, some examples of this are, Hop, Synapse. A bunch of these are focused on, or across, these protocols are focused on moving assets between rollups. And the reason that these exist is the canonical bridges, which again provide this deposit and withdrawal interface, tend to be too cumbersome or too slow to go through always for certain application use cases. Especially in the case of optimistic rollups, we have this withdrawal period of, I think, like 7 days. So I think we don't want to impose that latency on an application that wants to kind of do something for its users across rollups. And then finally, we have these like general message passing between rollups. And this is kind of emerging as a way for smart contracts that exist on different rollups to have composability, whether it's calling each other's functions or doing something a little more sophisticated than just moving assets between the rollups. And there's been kind of a few, I guess, early attempts in the community to establish some shared standards. So instead of each rollup having, its own custom bespoke interface that now all application developers need to go in and custom integrate with, people are trying to define standards for this. So there's one ERC from, I think, the Pool Together team that's shown in the bottom left here that's basically just trying to standardize these interfaces around something which is a little more sane and doesn't require application developers to have 30 different kind of adapters for all these different interoperability protocols. And yeah, just to highlight kind of why are we even doing this in the first place? Why are we trying to introduce interoperability between different chains or different rollups, different execution environments? And the answer is these new types of application architectures can actually unlock innovation and new properties for users. So just as like a very recent example, the A16Z research team posted an article. They've been doing kind of a deep dive on a bunch of different auction mechanisms. But they implemented a sealed bid auction using Aztec Connect, which is basically like this L2 that the Aztec team is working on. And in doing so, they kind of provided privacy to participants in this auction who are settling on L1, but maybe don't want to reveal their entire balances, for example. So yeah, this is just like really exciting. Once we get interoperability between what I call heterogeneous infrastructure, we can really begin to kind of like leverage a bunch of the innovation that's happening at the infrastructure layer in a single application. So right now there's like, tons of research, tons of R&D going into, basically new rollup architectures, whether it's for privacy or, performance. It's basically like a majority of the research community is focused on these problems right now. But there's not really great like interoperability between these different layers because they're all kind of designed aren't hearing you at my end. Yeah, they're all just kind of designed in different companies that maybe have a specific product in mind that they're going to build on top, but haven't really necessarily thought about how those products and those applications are going to compose with applications that are on other chains. There's also a lot of people working on light client interoperability, which is kind of amongst the research community, like I guess lauded as like the holy grail of interoperability. But there's, and this is kind of what the Cosmos ecosystem has been working towards for the past, I don't know, 4 or 5 years in their work on IBC, is basically having these native light clients for every chain that wants to be interoperable. And so in their ecosystem, they kind of make a bunch of assumptions about the consensus and execution environment that chains are operating, and then they're able to do these like client proofs between these chains. But even with this sort of solution, there's a bunch of problems. So for one, it's quite expensive to operate these like clients because you have to basically be processing every block header on chain. And as you scale the number of connections you have between chains, you have to do this for every chain you're connected to. And actually in the Cosmos ecosystem, this is basically like subsidized as a public good for people to operate these things, but there's not really a great economic model around how to fund these light clients. And the other challenge is these implementations of these light clients are quite complicated and require an implementation for every single state model. And so with all these teams kind of innovating on the VM layer, we have like all these new VMs coming out, Fuel, Aptos, there's a ton. There's probably a new one on Twitter today. The light client implementation for these new VMs is probably many years away. And these things don't generalize super well. And for rollups, especially, this is true. We basically don't have a good light client solution for rollups because of kind of how rollups are architected. So all that's to say, kind of light clients are not a panacea for interoperability, but we do need some generalized protocol for application developers to understand, to benefit from composability with all these different new infrastructure layers that are kind of spinning up, without, again, like you as a developer having to go through 25 different developer docs and say, what does their interface look like? So this is where this idea of modular interoperability comes in. And this is kind of aligned with the modular blockchain thesis, which is basically, once applications reach a sufficient operating scale, like let's say, Osmosis or DYDX recently is moving to a Cosmos chain. Once applications reach this sufficient scale, they want to move away from maybe one of these generalized execution environments to something that's much more well optimized to their application, and more kind of fine-tuned. And so we need to maintain the property of these protocols being composable with all the other DeFi Legos, but we want to move them off, let's say Ethereum L1. And so for developers to maintain that composability, we need to separate what's called the transport layer and the application layer. So the transport layer is basically how information moves between these chains. And the application layer is just basically what is the on-chain smart contract interface to actually send and receive messages between these different chains. And so you guys as dApp developers shouldn't need to understand all these details about the transport layer, meaning, oh, is this a rollup that's sharing, a settlement layer with the destination chain? Am I sending to a rollup? Am I sending to an L1? Am I sending to, a Cosmos chain? Do I need to use a different transport layer? Like as a developer, you shouldn't need to have control flow for all those different cases. There should be kind of like an application layer interface for you to pass messages, and basically to send and receive messages to and from any chain, irrespective of what the underlying kind of infrastructure and transport layer looks like. And so this is where Hyperlane comes in. Hyperlane is what we call a generalized message passing protocol, which provides this interface to your smart contracts on basically all of the chains that I've talked about thus far. So we're live on like, I think around 15 EVM networks, and we're working on a bunch of implementations of our spec across a bunch of other VMs. So we have a Fuel VM implementation, a C-level VM implementation, which is for Solana. We have a Cosmos SDK module. And basically, as as a customer of Hyperlane, or as a developer using Hyperlane, you no longer have to maintain, an implementation which is specific to Optimism or specific to Arbitrum or specific to one of these rollups, because you have this consistent application layer API. This is all with the caveat that, like, okay, we want to abstract away the transport layer from application developers because it complicates the implementation work, but we simultaneously want to allow those application developers to express their preferences for security. So we don't want to just say, okay, we're going to oracleize all this information at the transport layer between chains, and developers should just trust us. In the spirit of kind of modularity, we want to provide an interface for applications to say, hey, I know my application architecture the best. That's why I'm deploying on this specific chain, or I'm building a application specific rollup, etc. I know my application the best. I want to design and pick all of the trade-offs at every layer of the stack. And I want to be able to specify what security I require on messages which are coming inbound to my application. So, this can be like a function call from another chain. This can be an asset transfer. You need some way to say, okay, I have this much confidence that this message which says, let's say that it's transferring me 100 USDC was actually kind of is verifiable, basically, according to the source chain. And so in the Hyperlane protocol, we have this, again, another application layer interface we call the Interchange Security Module interface. And as a message recipient, or again, like an application developer like you guys, you can say, I want to use this specific security model for this, for messages which are inbound to my application. And so, today, our default security model that applications are kind of, if they're not specifying an interchain security module, they're opted into is basically this proof of stake validator set that we have on each chain. And if validators are lying about, or basically producing signatures that don't match what the source chain kind of says as what messages were sent out from that chain, then that can be slashed. But the beauty of this kind of modular interface is you can have an interchain security module, which is specific to your application. And again, you don't have to kind of assume some sort of like omnibus security model like a lot of the existing asset bridges or generalized message passing protocols kind of prescribe. So if you guys are familiar with like Wormhole or some of these big asset bridges, there's like a centralized validator set, and you're basically like trusting that all the applications that are built on top of something like Wormhole are just trusting that like that validator set will never be compromised. But it is the case that it might make economic sense for that validator set to collude and rug your protocol, and that's a pretty unfortunate situation that we're in because we have kind of this like third-party set of security providers, but with the kind of like ISM interface that Hyperlane provides, you can now introduce these application-specific security requirements. So you could say, I want the validators who are providing security on messages inbound to my application to have some exposure or risk to my application. So maybe they also need to be staking your application's protocol token. Or maybe you have a multi-sig that you want to ensure has signed off on, cross-chain governance or something that you're doing between chains that, again, now allows you to kind of express stronger and more granular security preferences as an application developer. Yeah, so hopefully that makes sense. This is kind of like something we're really trying to get people to experiment with and potentially come up with interesting security models, which are application specific. So, whether that's like a cross-chain stable coin, we want to introduce security mechanisms, which right now we have a couple off-the-shelf implementations available. We have this like proof of stake multi-sig. We have, we're working on an optimistic security model that's was kind of pioneered by the Nomad folks. But yeah, again, just to summarize, kind of, simple messaging API that exists across all these chains that kind of abstracts away the complexity or like idiosyncrasies of some of these different infrastructure layers. And then a way for developers to specify their preferences of like what security is happening at the transport layer, while still having that configuration interface at the application layer. So it's all just, simple smart contract interface. You just set an address. You don't have to run or operate any of your own infrastructure. So again, this is like modular interoperability. And then finally, what really makes this kind of scale well is we're providing the tools for developers to expand our protocol to whatever infrastructure they want. And this allows developers not to have to lobby for kind of inclusion. So let's say you no longer have to go to Jump or Wormhole and ask them and lobby them to bring their bridge to your chain or your rollup, which is a quite difficult process and probably is too much risk for them to take on. So instead, you can deploy Hyperlane to any chain you want. You can expand it permissionlessly. This is what the title of this workshop was about, permissionless interoperability. It's this idea that you can expand this interface, this messaging API, to any new VM or any new chain that you want. And you don't have to convince anyone to begin providing kind of transport layer relays to that new chain, because you can specify your own interchain security module on that new deployment that says, okay, I want my application to be on this new chain on day one, and I'm going to get kind of all of the composability from all the existing Hyperlane deployments inbound to my new deployment. And so we have like super simple instructions for how to do this on EVM chains right now. Again, we're working on expanding this to a bunch of other VMs, and we're also kind of excited to collaborate with people who want to see Hyperlane on new VMs or on new chains. But this is something that we'd really love to see people kind of play around with is, take Hyperlane, go check out the docs and look at what chains we're on. And if your application wants to be on some chain that we're not on, you can go and just like run a couple scripts and deploy the Hyperlane protocol to that chain, and now introduce composability for your application with all these existing network effects. So yeah, that's basically what I wanted to talk to you about today. I'm going to take a look at the chat and see kind of what questions came in, what kind of messages we would want to send between chains that are enabled by interoperability. Yeah, great question. So this goes back to kind of what I was talking about with what interoperability unlocks. So yeah, again, you know, in a single VM, like single chain monolithic worlds where we just have Ethereum, you know, all the smart contracts that are deployed on Ethereum can just atomically call functions on each other. And this kind of enabled a bunch of innovation that wasn't possible on Bitcoin, because now we can do, it's like arbitrary execution. We have this Turing complete environment. But the caveat is you don't get great scaling properties because all of your like verifiability needs to be super generalized. And what we're seeing kind of in the past couple of years is people want to push the envelope and get better performance or optimize the infrastructure for a specific product. And so they're deploying these app chains, they're deploying these rollups, but they still need to leverage existing network effects to either bootstrap their growth or just kind of, you know, get the same benefits of DeFi on Ethereum, in that you can leverage, you know, other protocols' liquidity or other protocols, you know, assets under management. And so this is the type of messages that you would want to send between chains. You know, you want to do a function call on a contract that's on another chain, or you want to, you know, send some assets or communicate some, you know, synchronize some state that's maybe across multiple chains. If you're, you know, maybe you're leveraging assets that are on some other chain or on Ethereum L1 for some new application, or maybe you're leveraging, you know, the Ethereum name service on your chain. You can do interchange queries, so you can like introduce oracles between different chains. You can use Uniswap, TWAPs on your chain for some, you know, DeFi protocol. That's the general idea. Does Hyperlane support Substrate? Great question. So we're working with a few teams in the Polkadot ecosystem. We don't have kind of like a Substrate SDK implementation, but we do have deployments on Moonbeam and I believe A-Star. And yeah, we're actually seeing some teams in the wild kind of prefer the Hyperlane interface to the native Substrate solution, which is this like XCM protocol. Can you talk on how does Hyperlane integrate oracles? Yeah, basic idea is you can basically send a message to some chain that you want to oracleize state from and say, hey, make this view call on this chain and send me back the response. So it's basically like a 2-hop message. We have a section in our docs. I might just hop over there real quick on what we call interchange queries, which allows you to basically create an oracle from any chain to any chain by basically doing these cross-chain view calls. So that's what this docs page is for. It's kind of a few other developer primitives on top of the messaging API that we talked about, which again abstract away some of the complexity here. But yeah, we'd love to see kind of anyone who's interested in getting these like cross-chain oracles to use this API, give us feedback. Yeah, if there's any other questions around that, happy to answer.
Hello. Can you talk about how Hyperlane provides infrastructure for swapping tokens from one chain to another? Like, what does it use?
Yeah, so It's a good question. So right now, we're not operating a like what you might call an asset bridge or a liquidity layer internally right now. So what we're doing instead is we are basically wrapping a bunch of other asset bridges on chains where they're available in the Hyperlane messaging API. So if you want to basically move USDC with one of these messages to another chain, you can do that with the liquidity layer API. And it will, go talk to the portal protocol to like mint and burn that asset, and then handle your message as it receives the tokens on the destination chain. We are working on kind of a more native liquidity layer solution, but yeah, right now we mostly just have adapters to a bunch of third-party asset bridges on chains where they're available. But that can also be, a project that you guys can build on top of Hyperlane is basically a more generalized asset bridge. We also have this like warp routes API, which kind of generalizes the ERC20 standard to cross-chain transfers. Definitely check that out as well.
How decentralized the infrastructure currently is for a liquidity layer API? Like, if I'm building a cross-chain swap that is like decentralized exchange that provides cross-chain swaps, is it a good idea to use Hyperlane?
Yeah. So, I mean, obviously I'm biased, but I definitely think so. I mean, right now, our validator set with like the default security that I was describing earlier is not very decentralized. We have basically like a bunch of people in our Discord that are operating these validators, but we're working on scaling up the economic security that they're staking. And we have a bunch of ideas there around leveraging something like eigenlayer and restaking and kind of bootstrapping more economic security. But I would say right now, if you want to do something with kind of a lot of basically like, I guess, economic risk, then you probably want to do the heavier lift of like implementing your own interchain security module, which kind of prevents this currently like fairly small validator set from having an incentive to I guess collude against your applications. But yeah, if you want to read more about the validators or understand kind of what our distribution looks like right now, definitely like hop in our Discord, and I'm happy to answer further questions around like the security status quo. Shankar, I'm honestly not totally up to speed on what our substrate integration looks like, but I again like would love for you to get in the Discord, and I'll connect you with kind of the right people there.
Hey, Yorke. I don't know if you saw the question from Meyer about what's a warp route mean.
Sorry, yeah, I missed that. So a warp route is just kind of our take on token bridges. We wanted to like differentiate the language a little bit because we've come up with some like different trade-offs. So instead of like, wrapping and unwrapping your token through some bridge like Wormhole, where you have this like honeypot of every single token that's in Wormhole functioning as like a bounty on the security of those validators, Instead, you can have what we call warp routes, which allows you to like introduce fault isolation between these different applications. And that's possible through, again, what I was describing earlier with this like modular security, interchange security module configuration, where you can have like application specific fault tolerances instead of like having this global shared security model. And there's a repo you guys can check out if you want to understand a little more about how warp routes work. You can basically clone this repo and launch your own warp route super easily. There's also like a UI template that you guys can basically just like clone and get one of these like fault isolated warp routes. Yeah, all this is linked on the docs.hyperlane.xyz. And yeah, please do follow up with questions in the Discord if you guys do end up playing around with anything we talked about here. Yeah, I think that's my time. So yeah, thanks so much, guys, for coming.
Yeah, cheers. Thank you, everybody, for joining us today. And thanks, Yorke, for the great presentation. And yeah, if there are any more questions, please just pop them into the Hyperlane's Discord. I posted the link a little while ago. So yeah. Cheers, everybody. Have a good day.